Let's start early. I'd like to thank you for being here. Today, I want to be different with other sessions. So because my presentation is based on the customer survey we did in the past, and we have some findings from that survey, and these findings cannot solve all of your questions. But I really hope that after the presentation, I really can have some interactions with you guys. And if you have some ideas, we can put it on the table, share with us. So we want to talk about Kubeflow because this is a Kubernetes session. So it has been 1 year since Kubeflow was in the market, and you probably found that in other presentations they talk about Kubeflow architect, they talk about Kubeflow ideas, intentions. So actually, we are one of the first one to use Kubeflow to the end users. So we found some problems with it. Sometimes it is very good on paper, but not so good in reality. So we found some issues and questions. We want to put it out there like a icebreaker for you to make it more practical and more useful. So my name is Xin Zhang from Caicloud Cloud, and also Mr. Deng Deyuan, also from Caicloud Cloud. Mr. Deng will answer your questions after the presentation. I'm here just to deliver this keynote. And first of all, please let me introduce myself. Caicloud is a 3-year-old company. Our founders from CMU, from Google, and Mr. Deng Deyuan was also won the gold medal of the World AI Robotic competition. Apart from this, we also have two open source contributions on all two open source projects, Kubernetes and Kubeflow. So these are the background of our company. So this is an AI session, and I assume that probably you have the background of cloud computing. So let me just briefly go through the background. So we're not only talking about AI research. In the morning session, I talk about in my keynote, AI research and AI commercialization are quite different. So today, I want to say at the outset, that we are talking about how to commercialize our AI technology. So I split my presentation or flow into 8 different steps. If you want to commercialize AI, first you need to have the business requirements for AI. What do you want out of AI? This is the biggest cost. If you found the business requirement, then you need to design your product. How can we, inject our AI algorithms into the AI framework? And then data processing, model training, model visualization, serving, product verification. And lastly, if we have an end-to-end product, we want to commercialize AI with business success. In the United States, there's a VC called Workbench. According to Workbench, 85% of the project fails related to AI. So how could you have a success business with AI? That is the most important thing. In this morning session, in the keynote, people have a lot of misconceptions with AI because they think that after we commercialize AI, that they thought that the most important thing is about the algorithms, is about the ML code. So this is the core business, the core success factors for the business, and other engineer related, they thought it was contributor, not so relevant. However, the leaders of Google Cloud called Andrew Moore, he said this. Actually, have contact with Andrew. I was working in Google, and he is when I was in college, he was my professor. And then when I worked in Google, Andrew Moore is the site lead. And then Andrew Moore go back to CMU Computer Science School, became the dean of the Computer Science School, and then he's in the business again. So he said, and I quote, that getting the technology to work in business is a huge challenge. So let's look at this diagram. This is one of my favorite diagrams. This is a real-world machine learning importance, machine learning code importance. As you can see here, the ML code is only a small fraction of the total business reality of AI commercialization. So if we want to innovate AI, what is the barriers? First, the data mode. So you need to aggregate data. Second barrier or second challenge is algorithmic differentiators. You need to have a very good one-of-a-kind algorithms to stay one-of-a-kind. Second, lastly is the product. Do you have a bottom-up product with your own data, your own capacity to have a very perfect product that is end-to-end? So open source is very popular, and the algorithms challenge can be solved in recent years. So the ML algorithms, it is not the most important thing with commercializations in the realities. When I work in Google, there are all the product lines requires a lot of jobs. So who develop those models? They don't have any background about machine learning PhD. They are software engineer. So I asked them, do you know math? Do you know statistics? They said, well, we don't have to because we have tools. We have open source neural networks. And all we want to do is to use these tools, to use cloud computing to quickly develop a training model. So to be more specific, when it comes to Kubeflow or AI pipelines, if we split it into more detailed steps, a lot of the steps are mathematics related, data related, and then we need to have a very solid foundation with data and then with training. And after the training model was launched, and then we need to manage it, just like managing a Java application. You need to manage your model after it was launched. So this is a very detailed pipeline for AI commercializations. First, you need to have a mathematical algorithms, and then you need to train, and then the model. So do we need to start from scratch? If that's the case, well, then I want to promote a Kubeflow. In 2017, on December 21st, 2017, we have the first Kubeflow blog on the internet. And the intention of Kubeflow is to use cloud computing to solve data scientists' problems. So to solve 95% of their problems. So the data scientist related problems are about engineers. And also our company, Caicloud, we've been in this game since the beginning. Another big contributor for us is we come up with the Kubeflow logo. So we have the Kubeflow logo designer here, Miss Wu Tingting. She is the Kubeflow logo designer. You can see that this is a very beautiful logo come by Ms. Wu Tingting. And also Dave is also here. As you can see, this is a quote, the credit goes to David Archik. This is the Kubeflow pipeline, and this is the English version of the Kubeflow, some steps. So we have this big picture, and then let's look at the status quo of the Kubeflow. What kind of questions is solved? What kind of problem is solved? Now our Kubeflow is transferring from 0.3 to 0.4 version, so it can actually solve some problems in some key steps. For example, when it comes to data transform, so they're using third-party tools, for example, TensorFlow or Python library to help you to transform the data. And when it comes to verification, we also outsource verifications to third-party tools. to help us to verify the data. And when it comes to training, when it comes to developing, we use mostly notebook, using this approach to edit the model online in real time. And then when it comes to data training, so how can we make sure that we can have large-scale training? We use Kubernetes dispatch capacity to define the resource. We can run it perfectly on Kubernetes platforms. And when it comes to serving, we use TensorFlow serving modules, and also we use selling community-related tools. Sorry about the technical issues here. The PowerPoint is on and off. So I just help you to review the Kubeflow. I believe that Dave will continue my presentation to be more detailed about Kubeflow. What is it and why we use it? So now let's go right into our main topic. Today we want to talk about the Kubeflow since its beginnings, our practice with Kubeflow, what kind of experience, what kind of lessons we learned from using Kubeflow in the past. So first of all, when we are doing the customer survey, and let me tell you the topic, and also let me tell you why we do this. Because we think when we are using Kubeflow, if you know your enemies, you will win with many battles. So first we have a survey to be more precise about who is our end user, what is their requirements, their behavior, and their preference. This way we can feedback to our own teams and make our service better. So all of my presentation was based on the report that we published, and we published that report on the Kubeflow community, and actually you can find that paper. It is more detailed about the questions and problems we found out. So if you're interested, please click the link and you will find our paper. So let me tell you about some of our findings. First, to clarify something, if we want to do this product, we need to make sure who is our target customer, or who is our end user. So in this context, there are different stakeholders. There are business analysts, there are staffers, there are data scientists who create the model, and there are also data engineers in charge of the overall AI infrastructure, architects, and also we have IT and DevOps guys. So there are three important titles here on this slide. We think that the business analyst is not the most important staff. I believe that Kubeflow need to empower developers to make all the developers to train their models in a more efficient way. So previously I talked about the end user. Who is our end user of Kubeflow? And now I'm thinking I like to introduce three different end user or our customer portrait, because these different customers have different portrait. Okay, so those are all using our Kubeflow, and let me introduce their customer portrait. So we split our customer into three categories who use AI. The first is the internet giants or IT giants or IT companies. They use a lot of very advanced IT platforms. Second, there are traditional industry players like energy, state grid, like finance, even manufacturers. They are traditional players in this industry. And the third customer is more advanced than the first categories. They are the research institutes like universities, like research centers in the company. So we found that these three customers for us, when they were using AI platforms, they have different requirements. So for the internet companies, they want to improve the resource utilizations, they want to speed up the iterations, but they don't have any requirements for the stabilities, because for research institutes, they are not create product online for the product. However, for IT companies, they care more about the stability, resilience, and the flexibility and elastic of the platforms. And for traditional players, they are not they're not embracing very advanced technologies. So these are some of our findings about 3 different kinds of customers. And also there are some anti-intuitive or counterintuitive findings. We found that in the past we thought that a lot of companies who use a lot of GPU utilization requires AI and Kubeflow. However, in reality, we found that a lot of customers, they don't have GPU or they don't have so much GPU utilizations. They just use very typical or typical AI machine learnings. They want to use machine learnings to help them their business. For those companies, they have a strong requirements to use AI platform. So that is the biggest pain point. That is the biggest question that Kubeflow should solve. Not only allocate the resource, not only manage the GPU. We found that there's a lot of customers. They can finish their training jobs on one servers with 8 GPU. Can already have a very high efficient training efficiencies. So when we position Kubeflow in the future, we believe that we need to have a very good allocations of the GPU, but that is one side of the story.
Developers of the our internal team as well as our customers externally distributed in the 3 different industries. So go back to our topic today. I'd like to divide it into 3 parts. First is your interesting point in Kubeflow and the pressing block issue currently, as the second part, which will block your further use of the open source platform. And thirdly is, although I can use it, it's not a blocking issue, but it's not a very good using experience. So we do not have enough motivation to use this kind of platform or model. We divided into 3 parts. So due to time restraint, Dave would also introduce a lot about the good. So I will be more efficient. I will only talk about the bad and ugly. So first, let's see the pressing issue here. First, about the file, we'll have a detailed description in the PP. Because time is limited, I only choose part of it. First is the multimodal training. What is multimodal training? Is because when we found in the practical commercial scenario, when we receive a request from the user, we need to schedule a lot of model and services to go back and receive the feedback. So here in the picture, we raise some examples from our customers. This is from an online clothes design company, and they hope that they could use AI to solve some issues regarding their design pictures, to have a conclusion from all the styles and designs. Maybe you cannot see the table clearly. They've divided into several parts, which is the high end and the middle and low end. So it's Chinese style clothes or European style clothes or Roman style clothes. And in the middle, the labels are maybe it's used in wear in spring or summer, and also have small categories from all the labels. Whether it is classical or modern. So when you input an image, we hope that we could receive the results basing on the images. We have all the labels on it, but the complexities in it are, the labels are not independent. Maybe we found already there is a label called Chinese, but maybe some other labels will not appear under this image, because in this scenario we must have a model first to classify first and give to the middle level to further label them. To put it in a word, for an image we need a sequence of models to finish the labeling and handling of one picture. So in practice, we have 16 models during this kind of process. So the question is, Kubeflow will package it, and during the scheduling, we will receive a GPU, although we one by one for the 16 models, it's separately operated using one GPU, but due to Kubeflow, it's a limited package. The 16 models will become 16 pies, and we have to use 16 GPU. So the question is that for many enterprises, they do not have so many GPUs. It's not necessary, it's a waste of resources. So that's our first problem we encountered with a blocker, resulting in that we cannot fully operate the platform. And then after discovering this problem, we have some discussion in the community. So first, go back to that we hope this session will be an open discussion, and that is what our thoughts during the discussion, whether we can use the TF serving. But it also has its limits, because in the future we would like to have a common platform. So the frameworks, we need an independent, a separated one. Also, the Seldom Core we've mentioned previously is a popular tool in other countries. We hope that it will have a more integrated user experience. And also the Apache Beam, whether we could consider workflow management tools like Argo. Recently also, Google launched pipelines for Argo. And also, maybe we can consider the workflow management tool called Lasso. That's the potential solutions. So because time restraint, we will go over this issue. If we are interested, we can have further discussion. And also we've discovered that the resource allocation is another problem in practice. It's not only targeting AI application, but also all kinds of application. It's a common problem, but for AI training business, it is more important, provided that we all know about Kubernetes. Its advantage is that we can at the same time run all those tasks and via the allocation to distribute our resources in the system. How much GPU you use. But the problem is how much exactly. If more, it's a waste of resources. If less, then it's not enough. So this problem, targeting the learning tasks, are very obvious and very vital. So when we are using it, maybe we have a 16,600 iteration, we have the problem of memory. So now the current version in the committee cannot offer a very suggestive information regarding which specific parts lack the resources. Maybe it's a CUDA memory, but during this process, it's via the menu operation, we need to debug. But the problem is not solved. When we operate it again, how to predict that this training, how much memories or resources needed in this training, or the times of iteration. So that's another problem we have when we want to use this kind of platform. We also discussed the related solution like Kubernetes. Later, we have a vertical pod auto-scaling. We can auto-scale how much it will be used and CPU used for this pod and the memory used. But we think this function is risky, especially targeting the GPU resources. And in addition, we think that we could maybe be more intelligent way to tell the users which stage are you on and your resources or the allocation problem, whether we can combine domain knowledge, because it's a iteration nerve network and the resources you used, we can combine with the domain information to design a auto-scaling targeting AI and machine learning. So just now I've showcased two practical issues that we need to solve. And later we'll introduce something that is not block issue, but without them, the user experience are not so good. First is the functions regarding data processing. First example I would like to use is the standard data label for supervised learning. So machine learning is taking a large part of the market, but the labeling is also very important, and we discovered that in order to do LCRD recognition, we need to have two engineers, full-time engineers, using 2 weeks of time to label the dataset. This is a very repeated work, a huge waste of resources. And during this period of time, we would like to extend to 10 people together labeling. We do not have a very good platform. We need to download it locally and manually gathering all the information. So there's not a very good way to collaborate. So the picture on the right, I also showed in the morning today. We use this kind of way to record that which file is the original one or which is labeled. So we need to combine all those results. And that is only one scenario during the pre-preparation for the data. Another one, I've listed all the demands. I believe if you are in the field of algorithm, you are not very, you must be very familiar with all those lists. You could also refer to the paper published on Google in 2017, telling how they use schema to do the data testing and how to support data splicing. In addition to divided the data set into different parts, we can also combine from attributes from other perspectives to divide the data into different parts. That's the solution you can also refer to. And next, we'll go back to the origin. Data comes from model. And data is changing all the time. Like our system is iteration all the time. Like the development system, we have the same request. When data is changing, how can we automatically trigger the new construction and adjustment? The CI/CD is also a very common pain point. When we do not have such kind of system, we discover that you are periodically manually update the online model. And next, for the demand, we call it model repository. So for today, the KubeCon is a very good conference. You've all known this issue. For our software, when it comes to Docker, we will store it in the repository. So one advantage is that it's good for us to do different versions of management and easy to find out the problem. And secondly, can distribute quickly. We can upload once, and whenever you want to run it, you can just download it. So for models, we have the same request and demand, and even more rapid demand. And also, we mentioned in the morning, the development of model comparing with classical software system is more complicated. We need to try more, to adjust more. Before it go online, you might have thousands of versions targeting different kind of configurations and super parameters. So we need to have a better management system to help you compare from different versions and shift from different versions. So this kind of repository is very important station for you to use. So here I also extracted a relatively good repository from ModelDB. So why I put this picture here, I would like to clarify that you may think that I package one model to a Docker mirror. Whether I can also use the Docker repository or hub. But for model, this kind of special software system, you have some metadata, or maybe its effects or its performance. What kind of framework is used during the training? What parameters are used? That's maybe cannot be seen in other systems, so we need this kind of special model repository. Although ModelDB have a very good demonstration, but it's not a native framework. We need to discover more solutions. So in addition to the ModelDB, we also discussed in the community whether we can have some open source tools from the third parties and how to track different experiments. Because why we are having all those versions is because we need to do more experiments to try more which super parameters are the best. So we have this experiment tracking on the upstream. I think it's more closely related in the integration with model repository. And last, I put this faster model development. So the scenarios, we have many. I've listed 3, and during the survey, I only have a misunderstanding that I believe Kubeflow will accelerate the development of model because it's have different machines and different cars to shorten the time. But later I've discovered that for many enterprises, their blockers are not the training and not during the training. Because the machines and physical machines are enough. Maybe GPU is not needed even, but the barrier is this aspects.
第二一个是对了模型以后怎么样去这些超参数稍微挺多的我的可能在这些其实很大的关键的花时间的点，哪怕它没有虚名，哪怕它运行的就是最简单的。 So it's just one very simple data processing.
怎么样去加速它的模型开发的这个那这里还有另外一个潜在的一个问题啊，解决这个问题还有一个办法，就是我们的企业里有一个所谓的这种老中医啊，大家会把脉啊，看到一个问题我就知道了，是吧？你就用这个模型，这个模型架构，就用这套参数。但现实的情况呢，就不像来自于这个应链这个workbench 的统计一样，数据科学家或者是网络中医是一个稀缺的资源。
It is very scarce in the company. It is much sought after jobs. In China, we have BAT. In the United States, we have Google. They have all the libraries. So for most of the companies, you need to have a value in your company to help you, but it's very rare. For example, according to McKinsey Global Institute, they predict that there will be a huge demand for data scientists. And on the other hand, according to LinkedIn, the job posting for data scientists over the past 5 years, job posts for related to data scientists increased by tenfold over the past 5 years. So we need these data scientists to help us to pinpoint the problem, but it is very hard to hire them. So how do we solve this? There are some possible solutions. We have another paper from Google. They provide an online service with a black box upgrading. It's a black box optimizations to help you to fine-tune your parameters, for example, O2ML. And in Kubeflow, there's a subgroup called KTIP. So using the similar ideas, follow the same line of thinking, and to combine it with ModelDB to do multi-experiment tracking and comparison and contrast. And also we have other solutions to solve that. For example, if it is a new context, rather start from scratch, we can actually transfer our learnings. We could actually copy other models. For example, we have TF Hub, and in recent years we have AI Hub, but they are just in the private alpha stage. So with TF Hub, we can also help you alongside with learning transfer. We can accelerate the fine-tuning of the model. So next, let me speed it up. to leave some time for Mr. Deng for a Q&A session. This is our solution, which is very simple, help you to improve the fine grain of the GPU. How can we have a better management and marking of the GPU? How can we have distributed training for different systems and during the host? How can we, just like JavaScript, how can we do the A/B test better and do the better CI/CD? So in the pipeline, we also have a similar ideas about better iterations, better inference for end user. So with this model training, this is a new system for us. We call it Cloud Native Intelligence. Based on Cloud Native, we can empower the intelligent application systems. What kind of thing we can do? Well, let me give you an example. There are some end-user applications, for example, on the e-commerce platforms. If we want to launch ourselves in the new market in overseas, we can actually use this model to test. And also we help the fashion industries to classify their pictures and mark their pictures. And also we can provide service to OCR, to government, to help them to empower the developers to do more. And last minute, any questions? Any questions? You can raise questions to Mr. Deng. Mr. Deng would answer your question if you have any. I'm sorry, the audience is not using microphone. The interpreter cannot hear him. So let me repeat a question here. So previously, we found that there's a resource scarcity when we are doing training. So how can we estimate how much resource the model need during training? It's a very tricky question. Okay, so I'm not involved in this talk. I don't know why they add my name on this chart, but let me answer your question. So it is somehow very hard to estimate the resource because we ask all the jobs to have limited resource utilizations. So we need to calculate GPU, CPU related resources. So up to now, there are several solutions to estimate the resource, how much resource we need. Well, first, we have all of the resource offline were separated. So because Kubernetes provide reserved resources, so we trying to make sure that the Kubernetes and Docker agent should not fail. That is the threshold. And when we are doing microservice, we have some findings. For example, when they are doing their own business, when the companies are doing their own business, all of their pod, all of their container, all of their jobs, task, and what is the department requires, they use annotation to tell our platform. And then when we are doing dispatch, there are some extensions we can do. And then our control found their historical data to suggest some resource to them and suggest some data. So we will make it transparent to our end users. The end users can look at our suggestions and then to allocate the resource. We don't do automations because it is very risky. We just do suggestions. So based on AI context, we base on their data usage, their models, whether they are using picture classifications, what is the size of their model. So based on all of those data, we will make suggestions for you. So then according to our suggestion, they will have a request and limit. So this will lower their questions. And also we will have some buffers added in. Previously, I talked to Ali's colleagues. We gave them 20% of extension, which to make sure that there's no problem of our suggestions for you. I want to ask you, you talk about Kubeflow and solutions. So let me ask you, how much of them are raw, some of them are self-made. So when it comes to Kubeflow, it was consist of different components, providing a lot of components that can be plugged in. For example, there are 10 to 20 components was raw, and previously we talked about pipelines to integrate all different components. So in our platform, there are 2 or 3 components was used by us. They are independent deployed, dispatched, because within the ecosystems, within the AI ecosystems, the machine learning requires different tools. We cannot integrate all the tools, so we just choose 2 or 3 components. Right. So I actually have 2 questions. The first one, in your slides, you mentioned Pachyderm. So actually, I used to research in that. There's a PFS support to dataset. So I don't know what is the future for this. Please tell us. And second, towards the end of the presentation, you've said that you have optimization to CPU and GPU. So we don't find it on Kubeflow website. So do you want to open that in the future, or this is just a private project for you? Thank you. So I kind of forget your first question. Let me answer the second one. So when it comes to GPU optimization, when it comes to Kubeflow, there is no optimizations for GPU. David probably will talk about this, and you can ask him. But for us, when it comes to GPU optimization, we only do, if you want to share, we can change the Kubernetes device plugin using 30 GPU. So you can request, you could probably say that we can provide an independent GPU for you, but if you want to share this with others, then we can provide you with 3 to 5 GPU. You can share this with others. You can share the capacity with others. So this is what we are doing based on Kubernetes. We will not change QDAP. And the first question is about PFS. So we didn't use that. We focus on their own data management ecosystem. Personally speaking, because they didn't provide so much notification, so I'm not sure whether we can call up some of the data that we need from all the data. So after our survey, we choose to do the dataset by ourselves, and we change the Git with reference to its own data structures. We do our own data management.